Welcome to the deep dive. So, imagine holding a single cable that costs like $760.
Yeah, which is basically the price of a brand new smartphone.
Exactly. And today we are decoding a highly specific product page from HDTVSupply. It's for the DVIGear DVI-2375-FOD optical cable.
Right, which sounds like a mouthful, but our mission here is to extract the hidden logic behind the high-end infrastructure that powers our data-heavy world.
Yeah, and we're using this 175-meter cable, which is over 246 feet, by the way, as our lens. Because, I mean, why does a single cable cost that much?
Well, when you look at enterprise-level tech, the price tag isn't just a markup. It's a reflection of extreme physical engineering.
Right.
To see why a single cable costs this much, we really have to translate the technical specifications into real-world physics.
So let's unpack that spec sheet. It lists a 50125 micron multimode fiber with 8x LC connectors. For those managing massive data centers or like broadcast facilities, signal integrity over huge distances is paramount. Let's get into the mechanics of that 50125 part first.
Sure, so the 50 refers to the microscopic glass core, which is just 50 microns wide.
Wow, that is tiny.
It really is. And the 125 is the outer cladding that reflects light back into the core. That multimode designation means the core is just wide enough to let multiple beams of light travel down the pipe simultaneously.
Oh, so at different angles without interfering with each other.
Exactly.
So instead of thinking about standard data lanes, it's more like shooting colored lasers down a meticulously engineered mirrored hallway.
That's a great way to picture it.
Right. So you can fire a red, green, and blue laser all at once, and because they bounce at precisely calculated angles of refraction, they never collide.
Yeah, and those 8XLC connectors essentially multiply that capacity. They give you 8 specific factory-terminated channels.
But if I'm just running data from point A to point B,
Right.
why is a multi-channel setup so critical for these commercial environments? Like, is an 8-lane digital superhighway really necessary instead of just a 1-lane dirt road?
Well, yeah, because you are dealing with massive commercial AV setups. Say you're routing uncompressed 4K video through huge matrix switchers to dozens of screens in real time.
Oh, right.
In those scenarios, signal bottlenecks mean total system failure. You are relying on those 8 independent channels to handle an absolutely punishing data load simultaneously.
Without drawing a single frame.
Exactly.
Okay, so we have this highly efficient, incredibly delicate glass lifeline. But if a business relies on this massive data flow, they can't afford for the cable to degrade or create a hazard.
No, absolutely not.
Which brings up the question of where a 250-foot glass thread actually lives inside a commercial building. The specs emphasize a Plenum-rated CMP black jacket. But let me push back a bit here.
Sure, go ahead.
Once a cable is hidden in the ceiling, why should we care about the jacket? I mean, isn't rubber coating just a rubber coating?
I mean, you'd think so, right? But the physical environment really dictates the engineering here. A commercial installation isn't running these cables across the floor.
Right, they're hidden away.
Yeah, they live in the plenum space. That's the dedicated area for HVAC air circulation above the drop ceiling or under a raised floor.
Okay.
So Plenum-rated is a strict fire safety classification. It's based entirely on the chemical makeup of the cable's coating.
Oh, which makes sense because if you run standard polyvinyl chloride, PVC cables through an air handling space.
You're asking for a disaster.
Yeah, a fire would melt that plastic and instantly pump highly toxic corrosive smoke into every single room via the AC system.
Exactly. So to get that CMP rating, the jacket is engineered with advanced fluoropolymers, which are actually similar to Teflon.
Okay, interesting.
These specialized materials inherently resist combustion and self-extinguish. If they are exposed to direct flame, they emit minimal, less toxic smoke.
So a significant portion of that $760 price tag is actually paying for chemical resilience that meets strict building codes.
Right. You are installing a permanent infrastructure piece designed to protect human lives just as much as it protects data.
Wow. What looks on paper like a standard, maybe even boring tech accessory, is actually a factory-terminated, high-speed, fire-safe optical system.
Yeah, it really forces you to rethink commercial spaces.
Totally.
Behind the walls of every hospital, broadcast studio, or skyscraper, there is this highly regulated physical nervous system, and it's engineered to extreme tolerances just to keep daily operations seamless.
Well, here is something to mull over before we wrap up. We've built our modern world on these specialized physical lifelines hidden out of sight. We constantly think of our data and internet as existing in a wireless cloud, right?
Oh, for sure.
But as enterprise data demands continue to compound and eventually push even multimode fiber to its absolute physical limits, Are we going to have to physically tear open the ceilings of every major skyscraper in the world in 10 years just to lay down the next generation of glass?
That is a massive undertaking to think about.
It really is. Think about that next time you connect to a network. That's all for today. Catch you on the next Deep Dive.